I watch the sun go down and up again and think of you. You're just so busy seeing red when all I see is blue.
All right. So let's say, and I think the best way to illustrate this is through an example, because the way they do it in the book, they use all these different variables and it gets pretty confusing. So I'm just going to write an example. Let's say we're given the double integral with these intervals of x cosine y dy dx. Okay, so I'm going to go a little bit along with the book, sort of, kind of. So this, as you can see, that's just a function of x, right? What I just circled. So let's just introduce g of x. Okay, some function of x, right? X alone. And on the other hand, cosine y is just a function of y, right? There's no x's like attached to it, like y plus x. Then that would be a function of x and y. But in this case, we have a function of x separately multiplied times a function of y. Okay, so when this happens, so when you have a function of x times a function of y, you can basically split them up into two separate integrals. So this is a pretty important one. Whenever you see it, it's a nice shortcut, and it makes everything look a little bit more simple. So when this happens, you can split up into two separate integrals of something of g of x dx times integral of h of y dy. Okay, so let's employ this. This is basically just saying that when you have something like this, so this is our important condition, then you can basically just squish all the x stuff into one single variable integral, put it in parentheses, and then do the same with the y's, group them all together, and then just multiply the two. Okay, so let's rewrite it like that. So our x stuff, this corresponds to x, the dx here, right? Because they're both on the outside. So it'd be from 0 to 3, and then we take our g of x, which is x, and our dx here. So basically what we did is just pull all of the x stuff to the left, and now we'll take whatever's left over, basically, all the y stuff, and put it in the other parentheses, set of parentheses. So then our bounds are 0 to pi over 2, because that was on the inner part. And then we have cosine y and our dy. Okay, so now at this point you can evaluate them separately and then just multiply them at the end, or you can just work them out as they are side by side in each line. So yeah, what I'm going to do is just solve them separately and then multiply. So this first one here, that's going to be 1/2 x squared, and x goes from 0 to 3. So then we have a 1/2 times 3 squared minus 0 squared. That equals 9 over 2. Okay, so this is our first parentheses, right? So this is 9 over 2. And then we'll do this guy. Maybe I could squish it in here. So let's see, 0 to pi over 2 cosine y. I'm going to try to write small, sorry. And the integral of that is sine y. So this is from y equals 0 to y equals pi over 2. All right, I'm going to go on to the next slide. So make sure you have all this written down. Okay, so then we get sine pi over 2 minus sine 0. And as we know from trig, this equals 0 and this equals 1. So as our final answer, we get 9 over 2 times 1, which, as we should know, it equals 9 over 2. Okay? So that does it for the concepts video for this section. And again, that was integration in two variables. So I hope that helps, and good luck on homework. I'm going to be making a video for including a couple of the problems from this section. So you could view that as well if you'd like to, and I'll talk to you then.